Welcome to Motive of Matter, where neuroscience meets the criminal mind. This channel investigates psychological and neurological elements behind extreme behavior. Today's episode explores John Wayne Gacy, America's notorious killer clown. We do not excuse or glorify his crimes. Instead, we ask, could brain injury, trauma, or neurological differences have contributed to his descent into violence? Between 1972 and 1978, Gacy murdered at least 33 young men and boys, many buried beneath his Chicago home. By day, he performed as Pogo the Clown and was a community volunteer. Today, we don't center on the grisly details, we examine his brain. Can neurological understanding help explain such violence, and perhaps help prevent future tragedies? Born in Chicago in 1942, Gacy faced an abusive alcoholic father who demeaned him. He had chronic health issues which his father dismissed as fabrication. At age 11, Gacy was struck on the head by a swing, developing a brain clot. Untreated for years, leading to reported blackouts and seizures in adolescence. Early head trauma during developmental years is a known risk factor in violent behavior. Studies have identified strong links between traumatic brain injury, TBI, and aggression or impulsivity, particularly when the frontal lobes, orbitofrontal cortex, amygdala, or insula are affected. Neurocriminal experts reinforce this. Adrian Raine, a pioneer in neurocriminology, used PET scans to study murderers, identifying reduced prefrontal activity and raising legal questions about biological evidence in courtrooms. Kent Keel collects mobile MRI scans from incarcerated individuals, examining links between psychopathy, impulse control, and brain structure. Robert Shug, a forensic neuropsychologist, integrates TBI and mental illness in violent offender research, co-authoring studies with Raine. Large-scale neuroimaging confirms this. Structural MRI of violent offenders showed reduced gray matter in prefrontal regions and increased volumes in areas like the cerebellum and basal ganglia, correlating with psychopathy, impulsivity, and recidivism risk. Another study found nearly half of murderers had frontal lobe dysfunction, with around 47% showing clear abnormalities on imaging. In legal settings, brain injury evidence has been used to mitigate responsibility. In R. v. Wood, England and Wales, experts argued that alcohol dependency syndrome caused subtle yet clinically significant brain changes, leading the Court of Appeal to accept diminished responsibility under partial defense for murder. Similarly, in R. v. Burgess, violent sleepwalking linked to organic brain causes was accepted as insanity, leading to psychiatric detention rather than prison. In Gacy's case, records of early brain trauma, combined with an abusive upbringing and emerging antisocial tendencies, align with the risk profile recognized by researchers. Child abuse plus mental illness plus brain injury equals heightened risk. Yet, not all with TBIs or harsh childhoods become killers. Neuroscience shows that brain injury may weaken internal brakes, but doesn't switch on violence. It's a convergence, biology plus environment plus psychology, that leads to tragedy. As always, we must never lose sight of the victims. Each life Gacy took was someone's loved one and irreplaceable. This isn't sympathy for the killer, it's about understanding how and complex factors can escalate to extreme harm. And when such evidence has real legal impact, from mitigation to delivering justice, we're reminded that science matters. Preventing future violence means confronting this complicated science. We investigate the brain, not to excuse, but to identify risk and intervene early. If this episode deepened your understanding of how neuropathology, trauma, and behavior intertwine, please subscribe. Motive of Matter will continue exploring the mind behind the motive with empathy, ethics, and evidence. New episodes every week. Thank you for watching, and stay curious.